All right, number 5 is a pretty challenging problem here, but it's got a lot of good parts to it. I've got a funnel. Its height is 10 from bottom to top. At any given height, the radius is given by this formula. And the first question is, what is the average value of the radius? So my average value formula is to take the integral from 0 to 10 of the r function with respect to h and divide by the interval width, which is 10. And so I'm going to have the antiderivative of this. The 1/20th is just going to be a coefficient. I'm going to have 3h plus h cubed over 3 evaluated from 0 to 10, and I'm going to divide that by 10. I get 1/20th. I get 30 plus 1,000 thirds. And I'm going to divide that by 10. I'm going to just make that 1/200th, which is the same thing. And then using a common denominator, I've got 90 thirds plus 1,000 thirds. And put those together and you have 1,090 thirds, but that's times 200, and so I've got 600 on my bottom. Dividing both of those by 10 gives me 109 60ths. And that's your answer for number 1. All right, find the volume of this funnel. So the way we want to think about this one is, if I were to slice this up from bottom to top, right, I would have circle after circle after circle after circle. So I simply have to find one of those circles and integrate from 0 to 10. And so the cross section of the circle is pi r squared, and r is this function, 1/20 times 3 plus h squared. The answer to this integral will be the volume of this funnel, right? dh. So integral from 0 to 10, pi I'm going to put on the outside, over 400 I'm going to put on the outside so that I only have to worry about squaring this binomial. So that's going to be 9 plus 6h squared plus h to the 4th dh. The 400 comes from 20 squared, right? 1/20th squared. So pi over 400, integral, I'll do the integral next. I'm going to have 9h plus h cubed over 3 times 6 is going to be 2h to the 3rd, right? And then I have h to the 5th over 5, and I'm integrating or evaluating at 0 and at 10. All this, pi over 400 again. This is going to be 90 plus 2,000 plus 100,000 fifths. Right? 100,000 fifths can be simplified. 5 goes into 10 twice, and then you have 20,000. And so I have 20,000 plus 2,000 plus 90, so 22,090 times pi over 400. I'm going to drop the zeros again and get 2209 pi over 40. And that is your answer to B. C is a related rate problem. It says the funnel contains liquid that's draining from the bottom at the instant when the height is 3. The radius is decreasing, so that's dr dt. At 1/5, decreasing means the rate should be negative. What is dh dt? This seems like the hardest part of the question, but it's actually the easiest because all I have to do is find a relationship between r and h, which I have already, and simply relate the rates. So if r is 1/20th times 3 plus h squared, the r dt is going to be 1/20th times 0 plus 2h dh dt. And if I simplify, I get dr dt equals h over 10 times dh dt. We're going to use the fact that h equals 3 to make this 3/10. The fact that dr dt is negative 1/5. And the last step is to solve for dh dt. So dh dt is negative 1/5 times 10 thirds. I get negative 2 thirds. The rate here would be inches per second.